Everyone. This is our class for, I guess this would be Friday, April 24th class. We're moving on to section 11.1, which is a test called ANOVA. The point of ANOVA is it's similar to the two-sample t-test, where you separate into two groups, and you compare the mean for some quantitative data between the two groups, except that you can use it if you have more than two groups. So it's a very analogous situation in terms of groups and then quantitative data for each group. And the main difference is the more than two groups. So it's like the two-sample t-test, but it works with more than two groups. And the two-sample t-test also produces a confidence interval for the difference between the means. ANOVA is strictly a hypothesis test. And it always has the same null and alternative hypothesis. So this is just a hypothesis test, no confidence interval. And the null hypothesis is always the same. The null hypothesis is that all the means are equal. Okay, so each group has a mean, a population mean, and the null hypothesis is that there's no difference between the groups in terms of their mean. All the means are equal. And the alternative hypothesis is just that the null hypothesis is not true. So the means are not all equal. So that doesn't mean they're all different. It just means they're not all equal. So if there's 5 groups, maybe 4 of them are same and 1 of them is different. Or maybe there's 2 that are same and another 2 that are the same but something different than the first 2, and then a third one that's like yet another different answer. So the alternative hypothesis is just that they're not all equal. So it doesn't really give you a lot of specific information. Like it's not going to rank the groups as like first, second, and third or anything like that. It's just checking to see if there's any difference between the groups. And maybe that's one group that's separated from the rest of them, or maybe all the groups are different. It doesn't distinguish between those. So how does this test work? Well, so I have an example down here. I typed these numbers in, but I don't want to get to that example just yet. I just want to give you a bit of a philosophy for how the test works. So there's a specific, ANOVA actually stands for something. It stands for analysis of variance. So ANOVA, this is analysis of variance. And Word is trying to fix my grammar here. But the AN is from analysis, the O is from of, and the VA is from variance. And so the idea is that each of these groups has a bell curve. And if we look sort of like for the bell curve that goes with each of the groups, if the bells overlap a lot, then it makes sense that like maybe the mean is actually the same for all of them. So like if the bells could like zigzag a bit, but like if all the groups have like bells that overlap, the mean could sort of like appear in like a different section of the bell for that sample for each of the groups, and it's reasonable to say that actually all the means are the same. It's just that like one sample was a little bit high, so its bell shifted a bit to the right. The other sample is a little bit low, so its bell was shifted to the left, but actually maybe it's possible that all the means are the same. Now, the time when they might be coming out different is if one or more of the bells is sort of like totally separate. Like maybe the bells are really narrow, so some of them are shifted to the side and it makes it so that the bells don't overlap a lot. Or maybe the bells aren't narrow and one bell is just like shifted way over to the side. So kind of what we're comparing is how wide are the bells as compared to how much are the bells shifted compared to one another. If the bells are very wide compared to the shift side to side of the bells going from one group to the next, then the null hypothesis could very well be true. If the bells are narrow compared to the size of the shift in the bells going from one group to the next, then that would suggest that the alternative hypothesis is true. So what we're doing here is we're comparing the variance in the size of, so we're comparing the size of the bells, which is kind of like the variance within each group, to how much the bells move side to side. That's like the variance from one group to next. So you're comparing these two different types of variance. That's why it's called analysis of variance. All right, so I'm going to try to, in this example, I'm going to try to bring up some of the graphs in Minitab so that we can sort of see, like, it might not generate bell curves, but maybe we can sort of see this left to right shift, like how much the groups overlap with each other. And that would sort of establish how likely it is that the null hypothesis is true. So I've talked for a while, so let's cut this video off and then we'll go on to a second video to start with this first example that I have the table for here.